Hello and welcome to yet another video on my channel. So in this video we are going to learn the algorithm of finding the particular integral of type 1. Alright, so the particular integral of type 1 is e raised to the power a times x divided by fd. Remember, this fd that you see in the denominator is essentially the left hand side of our auxiliary equation, where d is our differential operator with x as the independent variable d by dx. And in the numerator, you can see that it's an exponential function where a is a constant number, right? So a doesn't have any x or y or any variable in that, it's just a number. And the coefficient of x in the power of e, right? So essentially, this particular integral is going to help us in finding a part of the solution of the non-homogeneous linear differential equation with constant coefficients given by fd of y is equal to e to the power ax. Okay, now before we proceed with the algorithm, this is not the only equation that it can solve. However, um, let's go around and see what are all the different types of equations that we can solve using the type 1. Okay, so the non-homogeneous linear differential equation of the type fd of y is equal to ax can be solved using this particular procedure. An example is dy by dx plus y is equal to e to the power 3x, right? Okay. We can also solve the equation of the type fd of y as equal to e to the power ax plus b. You can notice that in the numerator there is a constant as well. And an example of this would be dy by dx plus y is equal to e to the power 3x minus 4, right? So 3x minus 4 is the exponent of e in this particular case. On the other case, let's imagine that we have got a raised to the power x, any constant other than e raised to the power of x, and even that can be solved using this type 1. Here, we just convert the base of the exponential term as e, and in order to do that, we use the laws of indices and see that okay, a raised to the power x is e raised to the power log a into x, right? So log a times x is basically log of a power x, and e power log of something is that something. So basically a raised to the power x is equal to e raised to the power log a multiplied by x. So the coefficient of x is log of a, and we can solve equations, for example, dy by dx plus y is equal to 3 to the power x. You see the right hand side, the rx is changing. Well, we can also solve the differential equation, the non-homogeneous linear differential equation with constant coefficients, with the right hand side to be with the right hand side, in this case could be a hyperbolic function, right? This is sine hyperbolic of ax. Again, a is the constant over here, and sine hyperbolic is defined as e raised to the power ax minus e raised to the power minus ax whole divided by 2, right? And an example is dy by dx plus y is equal to sine hyperbolic 3x. And since it can solve sine of hyperbolic x, we can solve cosine of hyperbolic x as well. And the expansion of cosine hyperbolic x is e raised to the power ax plus e raised to the power minus ax divided by 2. And and a simple example would be dy by dx plus y is equal to cosine hyperbolic of 3x. Okay, let's get down to the algorithm now. This algorithm is to find the particular integral for fd of y is equal to e power ax, where a is a constant. Okay, now this first step is to identify the operator function fd. Now, how to find out the operator function is, it's very simple. We can go back to the previous videos and have a look at it. So uh, we first write down the equation in the symbolic form, take out the y, and get the left hand side of the auxiliary equation as fd, that is operator function. After we identify what is operator function, we will identify what is the r. R is essentially the right hand side of our equation, e raised to the power ax, and then we will find out what is the value of a. So for example, it could be fd of y is equal to e raised to the power 3x, so a is equal to 3. So we find out R, we find out FD, we find out A, right? Okay. The next step is to find FA. So essentially, we substitute the value of A in place of D, and that will give us a number. And if this number is not equal to 0, we are done, right? So we'll find out the particular integral as r divided by fa. So r would be e raised to the power ax, or maybe we'll just substitute the value of a over there. Whatever is there on the right hand side, we'll write that r divided by fa. Fa, how do we obtain fa? Fa is obtained by substituting a in place of d. So this would give us the particular integral. Now, in the case where f a is equal to 0, we will find out f dash of a, which is differentiation of f with respect to d, and we substitute d as equal to a. So please remember that we cannot differentiate f a and write it as f dash of a, because f a is 0, is a constant. So of course f dash a will also be equal to 0. But what we do is we take this fd, right, the operator function, we differentiate that once, we get f dash d, and then we substitute the value of a and we get f dash a. So if this f dash a is not equal to 0, mind it that we are calculating f dash a because fa is equal to 0. So fa is equal to 0 is should be true, and f dash a is not equal to 0 should be true. So if both of these conditions satisfy, then our particular integral is going to be x multiplied by r by f dash a. So you see, in the denominator we are looking at f dash a, whereas in the outside we include a new x. X is the independent variable. Okay. Now, in the case where f dash a is also equal to 0, right? So we are calculating f dash a because fa is equal to 0. So fa is equal to 0, f dash a is equal to 0, and f double dash is not equal to 0, right? So how to find out f double dash a? We have already found out f dash d. So we differentiate f dash d with respect to d and substitute d as equal to a. And if we find that this number is not equal to 0, then our particular integral is going to be x squared multiplied by r divided by f double dash a, right? So you see here the power of x is 2, and here in the denominator inside the bracket we are looking at the second derivative of f with respect to d at d is equal to a. And this, my friends, is the algorithm to find out the type 1 uh, particular integral, right? So in the future videos, we will walk through very quickly about a few examples, and we'll move on to type 2 in a video much later. Okay, thanks for watching.